Well, good evening, church family. I am so glad that you've taken some time to join us tonight. Um, this is going to be, I hope, a really helpful conversation. There are so many different voices out there when it comes to COVID and vaccines and things like that, that I thought it would be helpful for us to hear from a trusted local source of information. So if you've ever had a sick child in the middle of the night, or if you ever had a medical crisis, you may already know Lance Jobe if you are in the Wenatchee Valley especially. Lance is a doctor with Confluence Health, and he has been serving in emergency medicine in our valley since 1999. He got his medical did med school at the University of Washington, and then your residency in at Denver Medical Center. Is that right?
Right. Yeah.
All right. Now, if I remember, like that was like you part of your residency was like responding to Columbine, isn't that right?
That's right. Yeah, that
Wow.
was my
Okay.
last year in Denver as a fourth year resident when that
Wow.
shooting happened. Yeah.
Okay. So Lance is the guy who's been there, who's seen it and has served people in a wide variety of situations, both the regular and the extraordinary. Um, let's see. He also, of interest, he has been a member of Columbia Grove for many years. He served on the leadership team here with us at the church. And he's also an avid hiker, an avid skier, an avid runner. He is a mountain biker. And as a guy who has mountain biked with him, he is too fast. That much is true. So I have a hard time keeping up with him. So anyway, he's a pretty amazing guy outdoors, and he's been a good friend of mine personally for many years. So Lance, thank you so much for taking some time to answer some questions and just help us to navigate this season and all this COVID stuff and all these vaccine questions. So I just appreciate your time.
Absolutely.
Yeah.
Glad to do it.
Now, I wanted people to get to know you just a little bit better personally, kind of before we dive into all the medical stuff. Now, I mean, now, so you're a Christian who is also a doctor. Now, so how did you first become a Christian?
Well, yeah, I grew up in a Christian family, went to a Christian school, so was very well steeped in Christianity. But I think it was probably kind of end of junior high, beginning of high school, where I think my own faith became much more personal for me. Um, and um, and so yeah, that's kind of, I can't say there was any particular, conversion experience. It was really just more of um, internalizing, my faith and becoming real for me. And yeah.
Yeah. Now, and so how did your faith shape your decision to pursue medicine?
Well, I was always very interested in, kind of anatomy and physiology. I took a class in high school that really piqued my interest in that. And, I've just always been amazed with how intricate, the human body is. And, still, even though we know so much, there's still a lot we don't know.
Mhm.
Um, and then as I went through the University of Washington and my undergraduate studies, I really just fascinated with anything living, whether it's
Mhm.
plants or animals, it's just amazing. And so that's really, just, you know, being interested in living things
Mhm.
kind of got me started on that road. But I think, also, you know, I, just caring about people
Mhm.
um, and I think our faith calls us to care for people, whether they're, rich or poor, or, whether
Mhm.
they're clean or dirty, and whatever the facet of life they may be in. And so I think that's a
Yeah.
part of it for me.
I've heard many doctors talking about how the intricacy of life has been something that's actually deep in their faith. Just the sense of like, wow, this is an amazing, complex design. The human body and life itself, and
Yeah,
yeah.
for sure. Yeah, I think, it's I guess for me, it's just so intricate, so amazing that um, I don't think that it could happen, just by chance.
Yeah.
Um,
Yeah.
but how God created us is, I think, an interesting, topic maybe for another time. But I don't think it came from nothing. So
Yeah.
that's
Yeah.
I think a big part.
And what are some other ways that your faith has kind of shaped your practice today? Like, how does it impact you?
Well, I think, in emergency medicine, we see, all facets of life that before I went into medicine, really didn't know even existed. And, we see the worst of people.
You mean
And
not everyone coming into the ER is well behaved? Is that what you're telling me?
no, 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 sometimes you're, cussed out, and, people are rude, manipulative, and that's not everybody for sure. And,
Yeah.
but that's definitely a part of it. And
Hmm.
so I think one of the things for me is, trying to remember that um, we're all made in God's image,
Hmm.
and that, no matter who somebody is, that's just foundational to being able to take care of them, is to know that they're made in God's image, and so to respect them, and still have boundaries, and
Hmm.
and and have expectations, but that we still treat them as a human being, whether
Hmm.
they're, a drug addict that I've seen for the 100th time, or the church lady, that comes in and is perfect. Um, we treat them all the same, and at least we try to. I won't say that I
Yeah.
meet that goal 100% of the time,
Yeah.
but
Well, I could imagine that would be one of the sources of strength to be able to try to be just consistently loving to whoever comes through those doors, to make certain that they get your very best efforts, even when you're probably not feeling at your very best.
right,
Yeah.
yeah, yeah,
Yeah. No, you have also been very much on the front lines of COVID care in our valley as people come through the doors and things like that. So you've seen people, with COVID, and I'm assuming it's sometimes even having to, refer people up to hospital stays or ICU or things like that. So what are some things that um, you just hope that people know about COVID?
yeah. So you have about 4 or 5 hours.
No.
Oh,
Okay,
um,
how about for the layman's version? So for
uh,
like in non-medical speak, no, you sent me a few slides, and I'll put up some of those slides as you talk about it, and I'll just, if it's okay, I'll just interrupt you if there's something that I don't understand, and if you're really mean to me, I'll start using Greek words and like deep theological terms that anyways. Just so just talk to me, talk to me like I don't understand too much, and because I probably don't. And just walk me through what you wish people would know about COVID.
sure.
Okay.
So, unfortunately, this has been an incredibly frustrating season of life for me, because there's been so much misinformation, for almost a year now, and sometimes coming from sources that should know better, and so it's extremely frustrating. But I think there's some basic things, that we can be sure of. One is that we are in a pandemic. It's not a made up thing. People are getting infected, people are dying, and people are having their lives dramatically changed, for who knows how long. So it's real. Um, and we know that there's a lot of asymptomatic transmission, and there's a lot of people that are asymptomatic with the disease. Estimates of 40% of people that get COVID have no symptoms.
Mm-hmm.
Um, and
Well, I might have been one. I was one. I mean, I tested positive back in November, and it just because I was aware of a contact, and then was able to quarantine after that. But so I'm one of those asymptomatic people.
yeah, and the problem with that is if you don't have any symptoms, you feel like you're fine, and then you can go, transmit that, to somebody else.
Yeah.
Um, And I remember for me, this was very clear. I think it was back in March, even might have been early April, but it was, some of the first cases I saw was a young couple in their 30s, and they both came in. They were symptomatic. We tested them. At the time, we weren't getting tests back for a day or two, and they were both positive.
Mm.
So, let them know that. And they ended up actually being hospitalized a couple of days later as they got sicker.
Mm.
And, but then the whole family came in, and there was a kind of different families living together. There's 14 total. So the other 12 came in, and none of them really had any symptoms, but I tested them all. And as I recall, I think 9 or 10 out of those 12 were positive. And that was for me kind of an eye-opening moment of, wow, this is real. This is going to take off like wildfire.
Mm.
And that's what we saw. So I, not only do I read about it and see it, but I've seen it myself, that, this is how it happens. And so because of this, these recommendations are that, that we do try to, limit our contacts with other people. And, so, if you're going to somebody's house for dinner or gathering in groups, you may both decide that, we'll take that risk and, but we're all feeling fine. But the problem with that is that, if you do have the infection and don't realize it, your decision or my decision, if I decide to do that, is going to affect other people besides those people that I'm having dinner with, because they may get infected and then they might go see grandma who gets infected and then she might die from it. And so the decisions that I make are going to have ramifications far beyond just the people that I interact with.
Mm-hmm.
So that's something that people need to realize. Now, as the vaccine comes out and as we can get this under more control and the number of people infected goes down, then the risk of participating in those things goes down, and then it's more realistic. But when infection rates are high, that becomes a real problem. And masks work. There was a lot of misinformation at the beginning that your oxygen levels would go down, and that was totally debunked. Think about if you have an operation, if it's a long operation, everybody in the operating room is wearing a mask, and they're wearing it for hours if it's a long operation.
Mm-hmm.
And it doesn't affect them. So, and we know that masks work. There's plenty of studies out there that show that. We're never going to have the gold standard randomized double-blind placebo-controlled trial, but because that would be impossible and unethical. But there's enough other evidence out there that shows that they work.
Yeah.
So those are some just kind of key points, I think, that I would say about COVID-19 that people need to realize.
Mm-hmm.
I think the other thing to know before we really talk about vaccines is to understand the depth of the pandemic. And currently it's a little over 25 million people in the United States have been infected. Our best estimates, based on epidemiological studies, is that probably 4 times that have actually been infected. So over 100 million people. Nearly 500,000 people have died. And that's a hard number to put in perspective. But if you think about a 747 jet that can seat 467 people, that's like one 747 crashing and killing everybody on board every single day for 2 years and 8 months. That's a lot of people.
That's a lot of people.
So, it's and that's not really even the biggest problem. The other problem is that people that get sick, this virus does a lot of things that other viruses don't. It attacks our blood vessels, our heart, even attacks the brain, which is why people lose their taste and smell. And some people have other, neurologic problems. They have strokes, heart attacks, blood clots in the lungs, and I've seen all of that come through the emergency department following COVID infections. So, it's real, and we've got to get it, control on it, and that's where I think the vaccine comes in.
Hmm. So, what are some things that you hope people understand about the vaccine, like how it works and what things they need to be aware of? Like, how do we make good decisions about that for ourselves?
So I think, one of the things that I hear from people is that um, they're concerned about how quickly the vaccine came to market.
Mhm.
So they're concerned that there were corners cut and that we really don't know if it's safe and effective. Um, and the fact of the matter is, I think that's a reasonable concern. But the fact of the matter is that the corners weren't cut, and that the safety studies were not any different than any other vaccine that's come to market.
Mhm.
Um, so one thing to remember is that this didn't just come out of the blue a year ago. We dealt with coronaviruses that were far deadlier than COVID-19 back in 2002 when the first SARS epidemic occurred. And then again with MERS, which was in 2012. Now, the difference with those two viruses, they were far more lethal, but people didn't transmit it when they were not symptomatic. So if somebody
Mhm.
got sick, you could immediately isolate them and cut off the infection. And that's why it never
So
really,
that's the difference, isn't it? Is that
that's
is that
the,
is that people that don't feel sick can actually be transmitting it now, when with the previous ones you had to actually be sick to
right.
get other people sick. Okay.
So yeah, so as long as you took care of somebody that was sick back then with protection and isolate them, you could stop the infection. And that's what
Hmm.
they did. But at the same time, people were worried that it could develop into, a worldwide pandemic like we have now. And so they actually did start working on vaccines back then. And they actually did have some development of vaccines. So it wasn't like these were completely new. They had worked on them. So they had kind of, a prototype in place, if you will. And so one slide that you could show is
This,
the first
this is the
one.
one with the arrow.
Yep.
Okay.
So
All right. I've got it up.
so that is kind of a vaccine development timeline for the Moderna vaccine. And people understood that this was going to be a huge deal. And I think scientists at top levels of government, and in our institutions, um, that were experts in this area realized this is something that's going to spread very rapidly, unlike the previous epidemics. And so you can see there on January 10th that China posted the entire genome of SARS-CoV-2. So SARS-CoV-2 is the virus that we're talking about. Um, COVID-19 is the illness that it causes. And so they basically posted the whole DNA of this virus. And within 3 days, on January 13th, National Institutes of Health and Moderna, they teamed up and they finalized a sequence for the vaccine that they were going to produce. So
It's almost like they knew what to do right away.
they did.
Yeah.
They did. And so within 3 days, they already were on top of this.
Hmm.
And by 2 weeks later, January 28th, they'd already selected trial sites. And then, let's see, February 7th, they actually produced the first batch of the vaccine. And by February 24th, they had shipped it to the NIH for review, and FDA approved what we call a phase 1 study, where we can actually start giving it to a small group of people. And then on March 16th, the first injection was given in Seattle as part of Kaiser Permanente's participation in this phase 1 study. So, we're talking about what, just over 2 months from the time that they knew the sequence of this virus to getting the first injection in. So that's pretty incredible. And
That's amazing.
yeah, and there weren't, any steps that were skipped in that.
Hmm.
Now, one thing to know is that they also knew very early on that this process, if we were going to get this out quickly, they would have to gamble and produce the vaccine before they knew it would even work. So they actually started mass producing the vaccine before they even knew it would work, in the hopes that it would, and then be ready to ship it out. And so they weren't cutting corners, they were just trying to compress the timeline by doing some things simultaneously that in the past might not have been.
Yeah, so there's some fiscal risk going on there, but there was really no medical risk.
Correct.
Okay, because yeah, if one of those vaccines doesn't work, then somebody's going to wasted a bunch of money.
Right.
Yeah. Okay.
Exactly.
Yeah.
So I think maybe the next thing is what I'd like to do is talk maybe just a little bit about the vaccine physiology. And so I'm going to, I know this can get really deep into the weeds, and I'm really going to try not to. And so, Andrew, this is your opportunity to keep me out of the weeds.
Okay, here you go.
Too deep, okay?
Okay.
So the next slide is really just a schematic of SARS-CoV-2.
Now, is this the white blobs?
This is the kind of cartoon with the red blobs on it.
Okay. Oh, got it. Right. Oh, like that ball that we all see.
Yeah.
The ball with the spikes.
Ball with the spikes.
Yeah, that's my technical term for you there, Glance.
And I'm pretty sure they're not red, but red.
All right. Okay, you keep nerding out. Okay, I'm with you.
And then the next one, is an electron micrograph. So super powerful microscope. That's actually.
So this is the white blobs where we can see the little spikes on there, kind of like the cartoon one.
Yep.
Yeah.
So those are actual viruses, SARS-CoV-2 viruses. Oh. And the reason why they're called coronaviruses is the corona, for crown, looks like a crown around them.
Okay.
I suppose, maybe not what I would have thought of, but anyway, that's how they got their name, is coronavirus.
So well, I guess scientists have to have imaginations as well. Right. So that's nice. Yeah. Okay.
So those are what we call the spikes on the outside. You might have heard of spike protein.
Yeah.
Protein is just a name for a molecule. And so these viruses are covered with this spike protein. And that's actually how they gain entrance into our cells and kind of take things over, if you will.
Yeah.
So the next slide I'm going to show you this is just a cell. And the only thing I want you to pay attention to is the nucleus of the cell. And then everything outside that is the cytoplasm. And you can think of it like the nucleus is the brain, and the rest of it's the body. So the brain's telling the rest of the body what to do. So all the machinery in the cell is out in the cytoplasm, and the nucleus has the DNA, and it's telling the cell what to do. If we go to the next slide, you can see that coronavirus schematic makeup coming down onto a cell surface where there's another protein that we call a receptor. And it's able to latch on to that receptor and gain entrance into the cell and kind of take over the cell's machinery.
Like it's an invader.
It's totally an invader.
Got it.
We're not going to go into any more detail on that. So now the next slide, this is the cell that we were looking at, and then we're kind of blowing up and looking carefully at the kind of interface between the nucleus and the cytoplasm. So the nucleus is the little darker shading with the double-stranded helix DNA in it. And then at the very bottom is the cytoplasm. And what happens in all of our cells is that the DNA, in order to tell the cell what to do, it needs to get a messenger out to the cell. And that messenger is the messenger RNA, or mRNA. And that's what you probably have heard of with the vaccine, because it's an mRNA vaccine. So what happens in the nucleus is another protein unwinds the DNA, reads the DNA, and makes a mirror copy of it. And that mirror copy is that messenger RNA. And the messenger RNA then is going to go out into the cell, and that's where it gives its instructions on what to do. So it's like the mRNA is almost like the nerves out to the body.
Okay.
So if we go to the next slide, at the very top, you'll see mRNA vaccine. And
Right.
on the side, it says lipid coat. So what they did was they took the messenger RNA that codes for part of this spike protein on the surface of the virus, and they put that mRNA in these little lipid globules, tiny, tiny little lipid globules that are able to get into the cell. And so you can see it's kind of merging with the cell there and releasing the mRNA into the cell. And then another part just below that, another enzyme basically is translating that mRNA to make the new protein, this spike protein. And then
So it's like it's training the cell to recognize the spike protein.
right. And it's almost like the cell is getting infected,
Right.
but it's just the spike protein. It's not the rest of the virus. So it
Right.
can't replicate. It can't do anything other than show the spike protein.
Yeah.
But
So
this,
it recognizes the spike that allows the bad stuff to get in, but it doesn't contain any of the actual bad stuff that gets in. It just learns how to shut it out.
exactly.
Yeah.
So
So
now,
this isn't modifying your DNA. This is just kind of like training a cell to identify an invader.
exactly.
Got it.
And
Okay.
that's a good point. What I forgot to mention in the previous slide is that once the mRNA is made, it cannot go back into the nucleus. So when the DNA, forms that mRNA, it leaves the nucleus, goes into the cytoplasm of the cell, and it can't go back in. And it's actually very unstable and breaks down fairly quickly, which is important to know with this vaccine. So when the mRNA gets into the cell, it codes for the spike protein. It can't get into the nucleus. It can't affect your DNA. And it actually gets broken down very quickly. And one of the reasons it has to be kept so cold is that it's super unstable. And so at room temperature, it will start to break down. And then you won't have anything in the vaccine. So
its effectiveness is fairly limited once it comes up to room temperature, which is why when it's brought up to room temperature, it needs to be used very, very quickly. Is that right?
right.
Okay.
Yes. So now this cell has this spike protein that it's presenting to the immune system. The immune system says, hey, we've never seen this before. Let's get rid of that. And so you get all this immune response, whether it's, and we won't go into the details, it's very complicated, but there's lots of different arms to our immune system. And the neat thing about this vaccine is it seems to stimulate all of these arms of the immune system. And so it's, which I think is why it's probably such an effective vaccine.
Well, I was hearing that like the Pfizer and Moderna, it's up in the 90% effectiveness range. That's pretty remarkable for any vaccine. Isn't that right? Or do I have that off?
Yeah, absolutely. I mean, there are some vaccines that have that type of efficacy, but for instance, the influenza vaccine on average is only about 50% effective. So,
okay.
This is far, far superior than.
But yeah, 95 is way better than 50.
Yeah, I'll take those odds.
Yeah. Okay. Yeah.
So hopefully that was a good overview and not too.
My brain doesn't hurt too bad. But so what? But what else do I need? What else do I need to know? So, okay, so because this is for the Pfizer and the Moderna one.
Right.
No.
Yeah.
Yeah. So that's that with it, and because the mRNA is a new-ish, but it's been used in other places, and isn't that right?
Well, that's what they had with MERS and SARS.
Okay.
And so it was an mRNA vaccine. It just wasn't widely distributed because we were able to control that pandemic with just isolation. So I think it's never been done on this broad of a scale. I think it's safe to say that.
But it has been, because it's been tested before, Now that we had to roll it out to the larger scale, there's a much greater assurance of its safety. Because if this was dangerous, we would have known, right?
Right. So I think really the key point here is that, after we, that first slide showing the timeline in March was a phase 1 trial. Then they have phase 2 and phase 3 trials. And so we could show the next slide, I think.
That's with the blue
Little graph.
line, blue
Yeah.
graph, blue. Yeah. Okay. Got it.
So I think I just lost it on my screen. But anyway, I've seen it enough times. I think I can talk people through it. So the graph is showing, this is from the Pfizer study, but the Moderna study looks about the same. And there's 2 lines on the graph. One line is people that just got placebo.
Yes, that's that blue line that's just kind of up on the average.
It just keeps going up.
Yeah.
The other line is the people that got the actual vaccine.
Right. So there's a dramatic difference.
There's a dramatic difference. And
Yeah.
so, people didn't know who, if you were a person in the study, you didn't know if you were getting the study drug or the placebo. You didn't, and the people giving you the injection didn't know. So that's what we call a double-blinded study, which is very important because that really takes out a lot of potential bias and confounding factors in a study. And and they had, a placebo group getting nothing but saline, and then somebody getting the drug. And so you can see that those 2 lines dramatically diverge around 11 days. And so there still were some infections in people that got the vaccine. But 11 days after the first dose, there was a dramatic difference.
Right.
And so, of course, the Pfizer recommends another dose at 3 weeks and Moderna at 4 weeks, just to kind of solidify that immune response. And so it was after the second dose is where they got their efficacy of 95%. But even first dose efficacy was very, very good. But it takes a little while. It takes, a week and a half to 2 weeks to build that immune response. So it's important to realize that once you get the vaccine, your first dose, don't change any of your behavior because you're not immune right away. It's going to take some time.
Right. Yeah, because it takes a while for your immune system to finish what it has to learn.
Right. Yeah, it's got a learning curve.
That don't we all? That makes sense. Okay.
Yeah. And I think there was something I was just going to say and I just forgot. So another thing to remember with these phase 3 studies is that they weren't, they didn't shortcut those studies. They had as many people in those studies as any other vaccine that's ever come to market. So we're talking, 30,000 people in these studies. These are big studies. And so I think between the 2, there was something like 25,000 people, and I could be wrong on those numbers, but something like that, that actually got the vaccine. And so when we look at safety, there was no, serious problems noted in any of those people with the vaccine. Now we have,
because it would have shown up between 25,000 people.
Right.
But somebody, if it was something major, somebody would have had something.
Right. Now, that's not to say that you could have some weird thing happen to 1 in a million people.
Yeah. Every now and again, we hear of things, like with the vaccine, somebody has a weird reaction or something.
Right. So, so there could be something that we may not know, but it's going to be super, super rare.
Okay.
And then you have to balance that with what can happen if you get COVID, which isn't super rare. So that's the important thing to keep in mind. Now, there are some, more common things with the vaccine. Allergic reactions can happen. And this was, certainly a concern with some people that I've talked with. But so far, severe allergic reactions have been about 0.001%. So that's 1 in 100,000.
Right.
Pretty darn rare. And think about that in terms of antibiotics. If you have pneumonia and get prescribed antibiotics, your likelihood of having an allergic reaction is actually far greater than that. And
Right.
yet, in 25 years of practicing medicine, I haven't had anybody decline the antibiotics for pneumonia because they were worried about getting an allergic reaction. And yet,
Sure.
the implications of getting COVID are, significant. So I think we
So
just
it's
have
one
to
of the things you have to kind of just keep in perspective. Like
right.
the numbers there,
Yeah.
but it's yeah.
Yeah. Perspective is the key.
Mm-hmm.
And there are some non-severe allergic reactions that people have had, and I've seen some people come to the emergency department and they were fine. They go away quickly. And then finally, there's the reactions that we would expect that you would have, that we would be worried if people didn't have, at least to some degree, and that's the immune response.
Mm-hmm.
So we're getting the immune system to recognize this foreign invader, and so it's going to have a response to that. And so that response, probably be a sore arm. Most people are going to
Right.
have a sore arm. And then especially even after the second dose, people can have some, fatigue, aching, low-grade fever. Some people even have higher fevers,
Mm-hmm.
but it only lasts for about a day and then it's gone. And you have no untoward effects after that. So again, much better than getting COVID and getting really sick from that. So again, it's that perspective, that risk benefit ratio
Yeah.
that's so important.
Well, that's where I mean, like I've got a picture of you getting the COVID vaccine,
Yeah.
and so did you have any? I mean, did you have any hesitation getting it?
No,
No.
I was super excited about it.
Well, you can't. Yeah, I mean, you're wearing a mask, so you can't like see. But so you're smiling.
Oh, I was
Sort
smiling. Yeah, I was super
okay.
excited to get it.
Yeah. No, did you have any headaches afterwards or anything like that? Did you any mild like that kind of stuff?
Yeah, the first shot, I just had a sore arm for a day, less than a day.
Okay.
The second shot, yeah, I didn't feel very good the next day. I was tired. I had like 104, 100.4 temperature,
Oh wow.
kind of achy all over. And so I just kind of laid low that day, but I knew that that was a possibility. So I didn't schedule anything, major that day. And went to bed early that night. And the next day I was 100%, went out Nordic skiing and didn't have any of that feeling of, after you're sick and you recover, you're still kind of weak.
Right.
None of that. I woke up at, 5:45 to go to a race with our son Matthew, and I felt great.
Okay.
So it just went away.
Just be able to just go on with life again and
Yeah.
good.
Yeah. So I think, just being aware that that is a very good possibility, but it's normal. It's not
Mhm.
a, problem with the vaccine. It's your immune system doing what it's supposed to do.
Well, it's learning quite a bit, so it's going to be working really hard.
Right.
Yeah.
It's funny that some of my partners in the emergency department didn't have any reaction at all. And they were kind of disappointed. They're like, man, I wish my immune system would have done something more. But
You and your
everybody's
underperforming immune system. Yeah.
Yeah, everybody's different in how they respond to
Okay.
things. So some people don't have that reaction, but it doesn't mean that it's not effective.
Yeah. Yeah. Now, just a couple of questions from people that were anticipating this conversation and sent some questions in. One is, so there's a number of different vaccine manufacturers, and they have different processes. Is there one that might be a better fit for a particular situation? I mean, the question is, so how could I know which of the different types of COVID vaccine is the best fit for me?
Good question. And I don't think at this point we probably have the answer to that question. But I would say the best vaccine to get is the one that you can get. So right now in the US, it's Pfizer and Moderna. And both of them they're pretty much the same vaccine.
Mm-hmm.
So now the other one that's come on the market that I don't know if it's actually been distributed in the US yet is the Astrazeneca vaccine.
Mm-hmm.
That uses another type of a virus called an adenovirus. So it kind of packages some of the virus parts into this other virus to use that virus to infect you, so to speak. It
So,
doesn't.
so that's a more like a traditional form of
It's
a
more like a
vaccine.
traditional vaccine.
Okay. Like a measles or
Um,
something.
yeah,
Yeah.
so it hasn't been shown to be quite as effective, but still far more effective than the influenza vaccine.
Mm-hmm.
And again, I think it's, you know, if it's a little less effective, but it's still the one you can get, that's the one you should take.
Okay.
So I have not seen as much data out on AstraZeneca vaccine. There's the Johnson & Johnson vaccine, which also hasn't done quite as well. So I think we just need to get a little more information on
Yeah.
them. Um,
But the ones that you're familiar with are the Pfizer and Moderna, and
right.
so that's the mRNA ones.
Those are the mRNA
Yeah.
ones.
Okay.
Yeah. Some of the others, the Johnson & Johnson also, I think, uses an adenovirus,
Yeah.
more traditional type of
And
vaccine.
did you get the Pfizer?
I got the Pfizer.
Yeah.
Yeah. Yeah. That was the first one that
Okay.
came. So
Well, there you go.
we're going to argue with which one I got.
That makes sense. Okay.
uh,
So here's another question. So people get their information from a wide variety of sources, including social media. And as you're probably aware, there's a number of videos out there on social media from people who are doctors, or at least they're wearing lab coats. That so they look official, but they're saying some things that are actually a little different than what you're saying or what we're hearing from the CDC or things like that. Like, can you give any advice to people of like how to know if a source that they're hearing from is reliable or not? Like how do you as a doctor figure out of the various sources which sources to trust?
so yeah, that's the big question of our day and age, right? Is with social media and so much information out there. So I think that one of the first things to do is whenever we're trying to answer a question, is realize what my own bias is.
Mm.
So if we take that into the context of the vaccine, if I am super excited to get this vaccine, my bias might be to ignore something that might be concerning about the vaccine because I just want to get the vaccine. I'm super excited about it. Vice versa, if I'm scared to get the vaccine or have some particular worry about it, I'm more likely to latch on to information that will confirm, my fears. And we call that confirmation bias. And so it's really just, it's not that it's a bad thing, that's just part of who we are. But I think it's recognizing that going into it, if I'm on the side of being afraid to get the vaccine, I just need to be aware of that and say, I know I'm going to be a little more likely to be biased towards a source that confirms that idea. So I think, yeah, first, what's my own bias? And then what's the source that I'm looking at? Is it a reputable source? In medical journals, there's some journals that are, very well known, and kind of everybody wants to get published in, the New England Journal,
Mm-hmm.
and, other journals are more obscure. And it doesn't mean that one's necessarily better than the other, but it's just something to think about. And you can have a study published in the New England Journal that has some real problems with it. So you still have to, think about what the information is. But, what's the source? And, when we look at sources on social media, when, somebody just is out spouting information, we don't know who they are, what their sources are, what their experience is. Um, Whereas, a news source, they have professional guidelines that they follow. They have editors that review things, and so there's a certain professional ethic that they have to follow. And so I like to think of it as, accuracy versus bias. And
Hmm.
so, bias we can deal with, but lies are harder to deal with. And so if people are telling information that's accurate, that's what's important. And then we can, tease out what their bias is and how that might, influence our own decisions on what to do with that information. And I would encourage people to, even just Google media bias
Mm.
and look at where sources of information are coming from. And there's a number of them that will plot a media source based on its accuracy and bias. And, what I want is something that's going to be high in accuracy.
Hmm.
Um, and then I'll be able to deal with if one is biased left or one is biased right, but give me accurate information. And so, yeah, I think, being really careful about what our source is. And if I see something on the internet where somebody says something, I might try to research, who that is or what that, maybe I hadn't heard of that news source before. So I'll kind of do a Google search and find out, I did that the other night with something and got to Wikipedia and kind of learned a little bit of the background of what that information source was. And so that helped me to, decide how much weight I wanted to put into that source. So I think that's important. Um, when we think about bias, for instance, in the pandemic early on, some people might recall there was a couple of physicians down in California who were kind of went viral on social media saying that this pandemic was being overblown. It's just like the flu.
Hmm.
Uh,
Yeah, I
and
remember that.
yeah, and so if that's, and I think our human nature is we don't want to believe that something bad is happening, right? We don't want to believe there's a pandemic. We want it just to go away. And so our bias is going to be more likely to latch on to something like that that confirms what we really want, which is to say that this isn't happening. I don't
Mm.
have to deal with this. But if we looked into the source of those two physicians, they were emergency physicians. They didn't practice emergency medicine. They owned an urgent care clinic. And at the time, number of people coming in for medical care was dropping precipitously because they were afraid of getting COVID uh,
Mm.
by going to a hospital or a clinic. Um, and so these two owned this urgent care center, and presumably their patient population was dropping, which means their income was dropping. And
Right.
so their bias was, we want to get our income back up. We want people to come back. And
Right.
so, and it was just a lot of misinformation. And if you dug a little bit deeper, the American College of Emergency Physicians came out very strongly against them, saying that they
Mm.
were not correct and that they were providing misinformation. And
Mm.
but you have to kind of look for those things.
Yeah, that even doctors can have biases that will um, limit their ability to be accurate.
Right.
Yeah.
Exactly.
Yeah.
So yeah, we have to look at the information, whether it's accurate or not, and then what the bias is
Yeah.
uh, that could be playing in. And then finally, I think it's fair to say, what do the experts say? What do the majority of the experts say?
Hmm.
Um, because if there's one lone voice out in left field saying one thing and everybody else is saying another, chances are that lone voice in left field is there because they're out in left field. Um,
Yeah.
now, granted, there are times when the
Right.
voice out in left field is correct.
But you want to take that into account, like this, the chances are greater that they are that lone voice because they're wrong than just because of the lone voice that they're right.
Absolutely.
Yeah.
Yeah.
Okay.
So yeah, we can't just take information in and just digest it.
Yeah.
We need to analyze the information before we take it in,
Yeah.
and which takes some work.
Yes, it does. Yes, it does. But thank you for your time, and just even to help us who, maybe don't have that level of medical training to try to sort some of these things out, get some basic understanding of how a virus works, or at least how an mRNA vaccine can work, and get some reliable local guidance on these things. And let's just want to say thanks to you and others who are serving on the front lines. I'm assuming that this has been a more difficult time than normal for medicine, and it also means that just for months, I mean, you and these brave others, you put yourself at additional levels of medical risk in order to help people and save lives. So just thank you, and just I'm for what it's worth. I'm praying for you on a regular basis, and I know that many other people are for you and our other medical frontline workers. So thank you.
Thanks, Andrew. Happy to help out.
Thanks.